So returning to our exam scores example, let's finish the forecasting that will show us, based on the two data points that we started with here, how many hours do we think we might want to spend in Alex in order to get that passing score of 80 for the semester. So I'm going to try and draw this line back in here again as best I can. We had predicted that it was somewhere around 75 was going to be the x value for this intersection point. But let's actually go in and find the equation for this line and then use that equation to make our prediction. So what's the first step in finding an equation for the line that passes through 2 points? What do I want to find first? The slope, m. And we can find it using what formula? Slope formula. y2 minus y1, so the difference in y values, divided by x2 minus x1, the difference in x values. And so for this particular example, my x2 and y2 come from this point 31, 39, so I'm just going to put those in there. By the way, one of the most common errors to make is getting the y's on bottom and x's on top instead of vice versa. Remember, the y's are always on top in the slope formula, so I want the 39 upstairs and the 31 downstairs. Okay, and then my first point, the x1, y1, 7, 17. So I'll go and I'll put those points in here as well. So 17 on top, 7 on bottom, and then subtract. 39 minus 17 is, I believe, 22. 31 minus 7 is 24. So 22 divided by 24, I could reduce that fraction into 11/12. So now, if I refer to the template that I'm using to write a linear equation, my template is y equals mx plus b. We now know at this point that we can replace m with the slope 11/12. So we'll do that. Right? And now we're part of the way there. Now I need to find my value for b. And finding my value for b is going to require me to substitute for x and y the coordinates of any one of the 2 points that we started with. We get a choice, so I tend to like to choose the example that has smaller numbers or easier to work with numbers. So if I were to do that, I would plug 17 in for my y and 7 in for my x. Let's do that. So then I end up with 17 equals 11/12 times 7 plus b. And so I just need to solve for b. I'll do that by clearing denominators, multiplying both sides by 12. Now I need to know what 12 times 17 is, unfortunately. 204. The 12 times 11/12, just as in our last example, are going to annihilate to an 11 times the 7 is going to give me 77, plus 12b. Then I'll subtract 77 from both sides. 204 minus 77 is going to be 127, I believe. You probably want to double check me on that, but I think that's right. Equals 12b. Then dividing by 12, b is 127/12. And that does not reduce to lower terms, so we are stuck with that value for b. All right, so big finish. I know I'm keeping you a couple minutes over here. 127/12. Ooh, that's not readable. 127/12. And so that's our equation for this line. And so our last task was then to figure out how to use this equation to make the prediction. How many hours should we spend in order to correlate with that score of 80 on the exam that we wanted? So to do that, we just substituted the value of 80 in for y, and then attempted to solve this equation for x. Let me clear out some space, and we'll do that calculation, and that's where we'll stop today. 80 equals 11/12 x plus 127/12. We'll clear denominators by multiplying both sides by 12. That's going to give me 960 equals 11x plus 127. We'll subtract 127 from both sides to get 833 equals 11x. And then we'll divide by 11. X is 833 divided by 11, which is not a particularly nice fraction. In fact, it doesn't reduce into lower terms than that. But if we pull out a calculator, which we'll do just for this example, and find out what 833 over 11 actually evaluates to, according to our calculator, 75.7272, et cetera, as a decimal. So after all of that work, that's the result of our forecasting. Our forecasting tells us that if we are to believe these two data points are representative of the trend in the relationship between the amount of time that you spend in ALEKS and the exam score that you earn, that getting an exam score of 80 correlates with having about 75.7 or so hours spent in ALEKS. And of course, there are all the statistical questions about whether these two data points are representative and all those wonderful things that I get to sidestep because I'm not a statistics professor today. And the whole point of this was to get us practice with finding an equation for a line that connects 2 points. By first finding the slope, using the slope formula, and then using that slope and the coordinates of one of our 2 points to then solve for the intercept. And then we can use that equation model to then make predictions and do forecasting and do other things that we might be interested in doing in an applied example like this one.